Okay, number 50. It says negative absolute value of 1 minus 2x close greater than or equal to negative 3. First thing I'm going to do is take care of the negative. I'm just going to multiply everything by negative 1. I do it on the outside. I don't go and transfer that negative inside the absolute value. Instead, I just get absolute value 1 minus 2x is greater than or equal to 3. Okay, so people tend to have trouble with this sometimes. I've got a number. I'm taking the absolute value, and it has to be bigger than 3. So, for example, it could be 8, because the absolute value of 8 is bigger than 3, because 8 is bigger than 3. It could also be negative 8. So, if I take negative 8 and plug it in where it's green, make it absolute value, then it fits this equation. So there's two equations that I get out of this. I could have 1 minus 2x be bigger than or equal to 3. That should make sense, because when I take an absolute value of a number that's bigger than or equal to 3, then when I take its absolute value, then it comes out to be bigger than or equal to 3 itself. The other one might be a little bit more tricky. I could also have 1 minus 2x be less than or equal to negative 3. So what I'm really saying is that negative 3, I could fall down here. That would be this equation. 1 minus 2x is less than negative 3. Because when I take that absolute value, it pumps me above 3, or the more obvious one is this one. It could be bigger than 3, and that is that right there. Anyway, so I need to solve each of these, so I'll go ahead and do that. And then I'm going to graph it at the end. So I've got, I can subtract 1 from both sides. Negative 2x greater than or equal to 2. Now I divide by negative 2. Careful, when you divide by negative 2, you need to switch the signs. X, when I divide by negative 2, I get negative 1. So x can be less than or equal to negative 1. Over here, subtract 1, I get negative 2x less than or equal to negative 4. Do the same thing, divide by negative 2. Gotta switch the signs. X greater than or equal to positive 2. So from here, I'm going to write it using a number line. So this is a big OR. And I'm going to write it using our notation, our interval notation. So on the number line, I'm going to go like this. I'm going to go negative 1, 2. Now it's less than negative 1 here, so I'm going to go like this, and I do a solid dot because they're less than or greater than or equal to signs. So it's down here, and then over here it's bigger than that 2, so it goes like this. The key is that this region in between 1 and 2 does not solve the equation. For example, if I plug in 0, right, 0 is between them. It's in here somewhere. If I plug in 0 to this, I get 1 minus 0. Absolute value of 1 is 1. Is 1 greater than or equal to 3? No, that statement's wrong. 1 is less than 3. So that area in between doesn't solve this. The way to write it using interval notation, and that's why I use that OR. If you say AND there, it just includes all numbers, and that doesn't work. Or actually, if we say AND, it's completely contradictory, but whatever. What I can do is go negative infinity all the way up to negative 1. I include negative 1. I put a parenthesis whenever I have an infinity. And then 2 comma infinity like that. Your book uses the U sign, I think, which is set notation for union. So it's saying this or this. You can also write or if you want. That's that.